This video discusses the most fundamental trigonometric identities. These are the ones that you're going to use the most. These should be your go-to. They're also the easiest of all the identities. These are also identities that would not be provided on any type of formula sheet for an exam. So first we have our reciprocal identities. We've seen these before when we first introduced our basic trig functions. So we know that sine of theta and cosecant of theta are reciprocals of each other. So sine of theta equals 1 over cosecant of theta, and cosecant of theta equals 1 over sine of theta. Cosine and secant are reciprocals of each other. Cosine of theta equals 1 over secant of theta. Secant of theta equals 1 over cosine of theta. And tangent and cotangent are reciprocals of each other. Tangent of theta equals 1 over cotangent of theta. Cotangent of theta equals 1 over tangent of theta. Our next three are our Pythagorean identities. These are used very, very frequently. The most basic Pythagorean identity is the first one, sine squared theta plus cosine squared theta equals 1. You're going to use this all the time when we get to verifying trigonometric identities and solving trigonometric equations. The other two Pythagorean identities can be derived from the first. Honestly, I only ever remember the first one, sine squared plus cosine squared equals 1, because I can derive the other ones. So let me show you how to do that. And I'm going to have bad notation here, just abbreviating. So if we have sine squared plus cosine squared equals 1, if I go through and I divide each one of these terms by sine squared, which is a legal math move because I'm dividing both sides of the equation, all terms, this is going to simplify and give us 1 plus cosine over sine is cotangent, and then 1 over sine is cosecant. And that gives us the third of the Pythagorean identities. I can derive the second one in a similar fashion. So I'll do that over here on the right. Again, starting with sine squared plus cosine squared equals 1. This time, I'm going to divide each term by cosine squared. Sine divided by cosine is tangent, that's squared. Cosine squared divided by cosine squared is 1, and 1 over cosine is secant, so this here will be secant squared, and that gives us the second of the Pythagorean identities. So again, I only memorized the first one, knowing that I can easily derive the other two, and honestly, it's the first one that we are going to use 80% of the time. Next, we have our quotient identities. These ones are familiar already to us as well. Tangent of theta equals sine of theta over cosine of theta, and cotangent of theta equals cosine of theta over sine of theta. Frequently, we like things written in terms of sine and cosine just because we do most of our work with that, and that's when the quotient identities really come into play for us. Negative angle identities are next. So here we have that sine of negative theta equals negative sine of theta. These are identities that I don't memorize very much. I just think about what's happening and then I don't have to memorize. In trigonometry, there are so many formulas, and trying to memorize them all is an impossible task. So if we can really understand where things are coming from rather than just rote memorization, it's going to help us remember more and understand deeper, which is really the point of it all. Okay, so here I have this little diagram where I have made angle theta. So I had an angle in standard position, so theta going up, and then negative theta going down, equal measure. So if I look at those two triangles, I see that the x value stays the same. See, they're both positive because we move to the right, But the y values are opposite. When we're in the first quadrant, that y value is positive, but in the fourth quadrant, that y value is negative. And r, our radius, is always positive. So I think about sine, and sine is equal to y on the unit circle. So what happens to the y value when I do an angle of theta versus an angle of negative theta? And we can see on this diagram that our y value has an opposite sign. So that leads us to the conclusion that sine of negative theta is equal to negative sine of theta. Now, looking at cosine, cosine of negative theta equals just cosine of theta. Because if we look at our two triangles, we see that for both of them, the x value is positive. So whether our angle is positive or negative, the x value doesn't change sign. So I use the diagram to help me think about sine and cosine, and then I can just get the others from that. So sine and cosecant are reciprocals of each other. Reciprocal means just flip over the fraction. It doesn't mean to change the number from positive to negative. So sine and cosecant follow the same rule. Similarly, cosine and secant, they follow the same rule because they're reciprocals of each other. Now tangent, again, I use my diagram. Tangent I know is y over x. And in the first triangle, y over x is positive, but in our second triangle, in the fourth quadrant, y over x is negative. So that leads us to the conclusion that tangent of negative theta is going to be negative tangent of theta, because in the first quadrant we got a positive, and in the fourth quadrant we got a negative. And then cotangent is simply the reciprocal of tangent, so it's going to follow the same rule.